This is JLN Murthy welcoming you to the world of real numbers. The adjective real before numbers indicate that there may be numbers other than real. Yes, it is true. The domain other than real is imaginary, which represents square roots of negative numbers. Okay, back to real numbers. These real numbers include rational and irrational numbers. Basically, rational is one which can be expressed as p by q, and irrational numbers are not expressible in the form of p by q. Yeah. So, what is complete number system? Real numbers include all rational and irrational numbers that can be represented on a number line. Yes. They encompass natural numbers, whole numbers, integers, fractions, and decimals. Yeah, these decimals can be classified into two categories: rational and irrational. Irrational decimal numbers will be non-recurring and non-terminating. Yeah, that we will discuss. The real number system is denoted by letter R in capital and forms the foundation for all mathematical calculations in algebra, geometry, and calculus. Okay, let us look at the key properties like closure law, the commutative, associative, distributive, additive inverse, and multiplicative inverse. All these properties hold good for real numbers. Okay. Now, what is the exact difference between rational and irrational number? As already expressed, rational number is one which can be expressed in the form of p by q, where p and q are integers, and they don't have any other digit in common as for common factor. Okay, so that is a rational number, and here denominator should not be equal to 0. That is p by q. If I express as a rational number, q should not be equal to 0. Okay, the decimal expansion is either terminating or recurring. If it is not terminating, it will be recurring. So that is the decimal group which falls under rational numbers. Okay, coming to irrational numbers. So what cannot be expressed as p by q is irrational. Yes. And coming to their decimal expansion, it is non-terminating and non-repeating or non-recurring, they call it, right? Now examples are root 2, square root of 3, which are non-perfect squares. Square roots of non-perfect squares are irrational. And we know that pi in a circle, we come across this very frequently. And pi is nothing but the ratio of diameter circumference to the diameter, right? Circumference is 2 pi r, diameter is 2 r. The ratio of that 2 pi r by 2 r, which is circumference to the diameter, whatever ratio is there, that is exactly the value of pi. Okay, it is irrational. Definitely, it is non-recurring and non-terminating. And e you might have seen in natural logarithm, we use that e, which is approximately 2.7 and so on, but it is also not repeating and non-terminating. So that is the value of e. And for example, another decimal one, 0.10, 100, 1000, where neither the 10 pattern is repeating, nor 100 is repeating. Always it is changing to different numbers. Okay. These numbers fill the gaps between rational numbers on the number line. So actually on number line, rational numbers are provided as fixed points, right? Between these fixed points, whatever is the length of the line is there, that is continuously filled by these irrational numbers. That's why your number line is quite continuous, right? Taking from minus infinity to plus infinity. Okay, what is the key insight here? The set of real numbers is the union of rational and irrational numbers. Together they form a complete and continuous number line. Yes. Okay, what is Euclid's division lemma? The fundamental division algorithm. Assuming you have two numbers A and B, right, two positive integers, they always can be expressed as A equal to BQ plus R, where Q is quotient and R is the remainder, right? A equal to BQ plus R. Now, we can always express any integer in terms of another integer with the help of Q and R. So A equal to BQ plus R, where R is less than B but greater than 0. So B is the divisor, A is the dividend, and Q is the quotient, R is the remainder. Fine. So, where do we use this? In HCF calculation, this can be implemented. Okay, let us see how it can be done. This lemma forms the basis of Euclid's algorithm for finding the highest common factor, HCF we call it. Okay, how to find it? Right, let us apply this division lemma to A and B. If a remainder happen to be 0, then B, the divisor itself, is HCF. In case it is not equal to 0, then you have to apply this lemma to B and R. Instead of A and B, you have to apply to B and R. You have to continue until and unless a remainder comes to 0. Once remainder comes to 0, the latest divisor whatever you have at that point, that becomes the HCF. Okay. Right, there is another method called prime factorization method. Finding the common prime factors and multiplying them. This is also one method of finding HCF. How to find LCM? Yes, prime factorization method. Take highest power of all prime factors. Okay. So with example, we'll understand better. We'll come to that. Using HCF, LCM can also be found by already having HCF on hand. Then LCM can be calculated as the product of the numbers divided by the HCF. Right. So for 12 and 18, for example, these are the two numbers A and B. Then HCF comes to 6 and LCM is 36. Because A into B, 12 into 18 divided by 6, which is HCF. Therefore, that comes to 36. Yes, 36 is LCM. Whereas 12 and 18, yeah, they have common multiple, which is the least of its kind, and 36 is the number. Okay, here is one important point. For three numbers, find HCF or LCM of any two first, then combine with the third number. Right. So you have to take two at a time and find out. Now, given a number, how to prove that it is irrational? So proving irrationality is that. So proof by contradiction method. So first of all, you are given a number, you will call it rational, and in the process itself will prove that our assumption that it is rational will be wrong. Then naturally the other one will be true, which is irrational. Right. So let's proceed how to prove that something is irrational. Let's take an example, root 2. Yeah, root 2, let us call it p by q, an expressible form of that rational number p by q. If p by q are two integers, which are, that is p and q should not have any common factor other than 1. That is coprime. Therefore, their HCF is 1. That's what he means. Because 1 is the highest common factor in that case. Yes. Now, procedure. You have to square both sides. That is root 2 on squaring 2, p square by q square. And p square comes to 2q square. This means p square is even. P square is even because it is getting a result something multiplied by 2. Therefore, p square is even. So p must be even. If p square is even, p has to be even. Therefore, p also can be expressed as 2 into something. Let us call it 2m. 2m square. 2q square. Yeah, 2m whole square equal to 2q square. And 4m square equal to 2q square. This implies 2m square is equal to q square. Yeah. This means q square is even. Yeah, this time again q square happens to be even. So q is also even. Now, find the contradiction. Both p and q are even now. Right, you have proved both are even. When both are even, contradiction of assumption that they are coprime is failing because 2 is common factor in that. Therefore, as we have proved that our assumption that it is rational has failed, so naturally it results in the given number being an irrational number. Therefore, root is irrational. Similar approach can be adopted for root 3, root 5 and other non-perfect square roots. Yeah, this already we have said. Yes. Now, coming to decimals, there are mainly three types of decimals. One is terminating, other is non-terminating but recurring, and third category is they are neither non-recurring, they are neither recurring nor terminating. That is non-recurring, non-terminating. Okay. First one, if you take terminating decimal, whatever decimal positions are there in that places, that many zeros if you place in the denominator, that comes to p by q form. Fine. So that is comfortable. Now non-terminating. Non-terminating but recurring. Once it is recurring, we can always multiply with a suitable number and subtract one from the other and express it as a fraction. Okay. Non-terminating and non-recurring, because we don't know what is the next number that is going to come because it's not repeating, and also non-terminating because it's going on indefinitely to infinity. Therefore, such numbers cannot be identified to certainty at what expression we can present them. So it cannot be shown as p by q. Therefore, they come under irrational category.